Greetings for the day. Welcome to my IBDP Physics HL course, A.1 Kinematics. The learning points for the video. The theme of kinematics is space, time, and motion. Kinematics is the motion of an object without external forces. And the three command terms are position, velocity, and acceleration. Let's talk about position first. Position is the location of an object based on its reference frame. For example, here we can see there's a teacher who's at the left of the boy. So the boy becomes the reference frame. On the other hand, the teacher is on the right of the girl. So the girl becomes the reference point. So position is basically the location of an object based on a reference point. Distance and displacement. Distance, it is how far you have traveled from A to B. It is a scalar quantity described by magnitude only. So for example, 15 meter per second. So 15 is the magnitude, which is the length between two positions. And displacement, on the other hand, it is a vector quantity described by magnitude and direction, and is the shortest distance between two positions. Change of position is displacement. So by vector quantity, we mean where there's the magnitude and direction. So for example, if there's a velocity of 15 meter per second, if it's positive, that means the object is moving to the right. But if it's negative, it means it's moving to the left. Now let's take an example of distance and displacement right over here. So if let's say I'm moving from point A to point B, then the distance is 1 kilometer as denoted here. And if I came from B to C, like this is a one-dimensional reference frame. So now if you're moving B to C again, now that's 500 meters. If we were talking about distance, it would have been 1.5 kilometers because it's a total distance and sorry, it is a total journey traveled. So from A to B to C. Excuse me. Now moving on. And if it was displacement, then it would be the shortest distance. So we are going from directly A to C, which is 500 meters equally placed. I forgot to mark that, but yeah, equally placed. So now A went to B, B went to C. So that's just 500 meters in terms of displacement because it was positive 1 kilometer and negative 500 meters. You know, so that's how it becomes 500 meters. Next is speed and velocity. Speed is again a scalar quantity which uses distance instead of displacement. So it's as you can see here, speed is equal to distance over time, while velocity it is the rate of change of position. I hope you remember displacement was the shortest distance between two positions, right? So this is similar to that. It is the rate of change of position. It is a vector quantity which has the unit meter per second or ms negative 1. In IB terminology, we use ms minus 1. So both of these have the units ms negative 1. And velocity is equal to displacement over time. So now we'll be taking a lot of looks at velocity in the IB curriculum. So for average velocity, we have velocity calculated from overall displacement of the overall journey. This considers that the trip took place with constant velocity and in one direction. So as we can, let's go back to this example. So velocity is basically one direction, so it's only going here. If you're taking the average velocity, if it was A to C, we would forget about B, right? Because velocity is uses displacement and displacement was 500 meters. So it's in one direction towards right. If C was, let's say here, even though it moved from here, we would directly take it from here to here, the velocity. That is basically what average velocity is. On the other hand, instantaneous velocity is how fast an object is going at that moment in time and in which direction. So direction matters here and the moment in time matters here. So I'll be better showcasing it to you in the next slide. I have a graph made for this exact reason. Um, then average velocity calculation is done using two formulas. One is U means initial velocity, V means final velocity. So initial plus final upon 2. So you just take the average velocity of the starting and the ending. On the other hand, we can also do displacement over time. So V is equals to S over T. Acceleration. Acceleration is rate of change of velocity, and it has the unit meter per second squared. So ms negative 2 here. So acceleration is basically velocity over time because it's the rate of change of velocity, and rate of change is calculated over time. Now let's take an example of acceleration, which is the most prominent one we have, which is gravity. And it is a very useful thing in the upcoming topics for 8.1 as well, where gravity is an acceleration. As the longer the object falls, the faster it gets. So let's say these books over here, they are dropped below, right? So over here, the speed would be lesser compared to here because acceleration acts and the object falls faster and faster as it gets closer. I'm sure we all have seen if you want to try a drop like a ball or a pencil on the floor, and you'll see it gets faster the more it is towards closer to the ground. Now, SOVAT formulas are the most important thing for 8.1, and they would be used like a lot of times. So you can see the key over here. I'm sure you don't need to be explained that, but let's just look over these. S is equals to ut plus half at square. S is equals to v plus u times t over 2. V square is equals to u square plus 2as. A is equals to v minus u over t. You can just pause the screen and note it down. I'm recommended take notes as you go. It would be very useful for the IBDP program. Meaning of signs in vector quantities. Now, this is a very major and important factor when you are looking at vector quantities, the signs. So, if like I'm just taking an example of positive, I think you'll be able to understand the negative as well. I have an example for you. So, if positive, let's say I have an object here, if it moves towards the right, as I mentioned before, it would be going in the positive direction. But if it was on the left side, it would be in negative direction. Now, displacement, as we talked about before, S, body has moved to the right. So if it's like a positive displacement, it means it has moved towards the right. Velocity, body is moving towards the right. So let's say it was 40 meter per second square. No, 40 meter per second. So it will just be going here and yeah, moving forward. But acceleration is a very interesting point of this. Body is either moving to the right and getting faster or moving to the left and getting slower. Alright. So to better understand this, I have an example here. Let's look at this real quick. If a car is traveling in the left direction, then the values would be negative because they are vector quantities, right? So if I had an object which is moving towards the left, so let's say it has a speed of negative 10 meter per second since it's moving to the left as described before. Velocity is negative 5 as well. The like u is like the initial velocity, v is the final velocity, right? So let's say it slows down, right? So it is slowing down as mentioned before, and time is let's just say 5 seconds for a matter of convenience. So using the formula described before, a is equals to v minus u over t. So we find it to be 1 meter per second squared, right? So this is positive. So therefore, or moving to the left and getting slower. Now it's similar to that if you take negative, displacement has body has moved to the left, velocity is body is moving to the left, and body is either moving to the right and getting slower or moving to the left and getting faster. Next, acceleration of freefall motion. So now this is a better example to what I have mentioned before. This should be above. Sorry about that. But yeah, body is falling freely on the earth, fall with an acceleration of 9.8 meter per second squared. Since acceleration is constant and SUVAT formulas can be used to solve problems. Because here A needs to be constant as you can see. So that's very important. Therefore, with gravity, when a ball is moving down, I'll come to the example real quick. But yeah, it can be used to solve problems when we are looking at an example of the ball. The time to fall, t, and displacement s are related by equation 1. Equation 1 was, you know it, s is equals to ut plus half at squared. That's the first equation basically. Uh, Coming back. So, and if the body starts from the rest, the new equation is half at square because u is then 0. U is the initial velocity, so it's just 0. This should also be 80 squared, but that's fine. As a is constant, a graph of st, so let's say s equals half at square, right? A is just constant, you can remove that. And half a is put up, it's totally a that constant. So a graph of s and t squared would be a straight line, so directly proportional with the gradient half g because A is, you guessed it, gravity, so 9.8 meter per second square. That would just be the gradient. Now, the interesting facts, graphs, and very important in the IB curriculum. So let's say, like you can just see the examples here. I don't think that's gonna be much complicated. Like clearly, like even if you forget this, we can it can see here that A is just stopped in time. The displacement is not increasing nor decreasing over time, so it's just a stopped object. B has increasing displacement, so the length is increasing over time, so that means the velocity is increasing as well. C, on the other hand, is it's decreasing, and D is the motion, like the object is accelerating, and it's constant acceleration as you can see. And others are straightforward. D is the only one accelerating. Velocity of B is positive and constant. A is just not moving, so 0, and C is decreasing with constant velocity, so it's negative because 0 is here, and is accelerating, so the velocity is increasing over time. Voila. And the gradient of the SNT graph means displacement and time graph, gives velocity. So the the gradient of B gives the velocity, gradient of C gives the velocity, and gradient of A is simply 0 because y2 minus y1 is 0. So yeah. So the gradient formula is y2 minus y1 over x2 minus x1. So that's how we can see that. And then gradient of v and t graph gives acceleration, area under v and t graph gives displacement. So the area under b, like if you just take the area of this rectangle, it would give displacement. And like if you want to see that, you can just solve a few equations and you will get why that is. It's not very relevant, but yeah. Just know that V and T graph gives displacement. The area under V and T graph gives displacement. And then area under A and T graph gives change in velocity. It's not velocity, it is change in velocity because acceleration is uh, like change in position over time, right? So the area under that gives change in velocity. Yeah, now we have this here instantaneous velocity, like I talked about before. So over here, like the graph, you can see displacement time. Now, let's say it's a curved line, right? Because the body is accelerating, it doesn't have a straight line. So how would we check the that from? Velocity. So what you do is, let's say I have this point over here. You can see the arrow as well, I hope. But yeah, so we'll just make a tangent to this line, like you can see in the triangle here, and then you calculate the gradient of this tangent. So y2 minus y1 over x2 minus x1, as I talked about before, delta y over delta x. So now here it would be delta s, delta displacement over delta time, change in time. So that's how you can get instantaneous velocity. Now, this is the most, I think, complicated part of the A.1 entirely, which is projectile motion. Now, projectile motion is two-dimensional. However, if we take components of all the vectors vertically and horizontally, projectile motion can be simplified to two simultaneous one-dimensional problems. So, horizontal component and vertical component. Now, let's see this ball. So, the ball just goes above and then comes down. Like you can see everything is labeled here. Let's take this as the starting point, A as starting point, B as middle point, C as ending point. So is here displacement is 0, of course, velocity. So in horizontal component, you always take the cos theta. We have a huge explanation for that as well, but I'm not getting into that right now. Comment down below if you want to understand why that is. But yeah, so Now, if the ball is moving above, horizontal component is just v cos theta. Theta is whatever the value would be here to the plane. And acceleration is zero because it's a horizontal component. Nothing can. Oh yeah, we are taking air resistance, friction, everything negligible over here. So yeah, A is just simply zero. So no horizontal component there. At B, however, the displacement is r by 2. R is the total distance, the displacement it would go, and it's just r by 2. Acceleration is again zero, velocity remains the same. Similar here, the displacement is just r. On the other hand, vertical component has displacement zero. Of course, it's not going above anywhere, it's still on the ground. It is a velocity of v sine theta. Now, for vertical, we take sine theta and acceleration is negative g. Remember, acceleration is a vector quantity, so direction matters, and gravity is downwards, as you can see this line over here. So it would be negative 9.8 meter per second squared. At B, the height is maximum. It's the max height, right? So and velocity becomes zero because now it has gone the maximum part it can. It doesn't have any more speed or velocity to go through, and acceleration is still negative g. At c, the displacement is again zero. There's only one maximum height, and velocity is negative v sine theta. Because it came down, velocity is also directional, so it's negative v sine theta. Acceleration is again, of course, negative g. So that for this motion. So for horizontal motion, a range, you can calculate range using r is equals to v cos theta t, or s is equals to vt. Like if you rearrange this right here, it would become s is equals to vt. It's like we can directly find it by s is equals to ut plus half at square. So in that, if you take a is equals to 0, then it just becomes s is equals to ut, right? So that is literally what this is. In horizontal motion, the velocity remains the same. So if you take v or u, it doesn't really matter because the velocity is same, because we are taking acceleration as constant. And in horizontal motion, we just need to look at the starting point of it. Of course, the velocity would change, but at the start, you would just take it as the same. So you always take the starting of the velocity of the motion. Vertical motion, on the other hand, we need to calculate h, which is the height, the t, which is the time. So these are the formulas which we can use, and this is like the most relevant formula out of all. Whatever happens, you can just use this. Like this is what I found to be the easiest in the curriculum. Just do s is equal to ut plus half at square and calculate everything with half at square. You can find time. Now, if we are solving a problem, then we need to find time. So use this formula. Boom, done. Just do vertical motion and horizontal motion differently, and you will be fine. Now this is the other point of it, which is the projectile motion with air resistance. Oh yeah, projectile motion would take a lot of practice, so I would recommend you to do that. It took me time to understand it, and it is a useful topic. Oh, because once you get the hang of it, it becomes very easy. Then projectile motion with air resistance. Air resistance opposes motion and increases with the speed of the moving object. It was ignored until now, as I mentioned. It was kept to be negligible because it's like a part of the curriculum to just ignore it most of the times. But for air resistance, you need to know how the graph would look. So if it is without air resistance, we were seeing it was a parabolic shape, right? So this, if you like divide the line by two over here, like add a line to divide it by two, it would be same. But over here, this line is steeper because air resistance makes it go less horizontally, less far. Like you can see, it's literally divided by two here. Like it's just an example, not to scale, but yeah. And the line here is steeper than this curve. You can see. It's like notice how the range is a lot less, the maximum height is a lot less, and this is not parabolic anymore. Thanks for listening, and this is the end. Thank you.